Well, another Monday is here. I went ahead and sent you guys a little practice test last time without me talking, and seems to have been pretty popular. Hope it'll help you some with your ASE tests. The ASE has extended us till the end of the year. The ones of us that I had some that were expiring in July that I was going to need to re-up on, but of course, if you're like me, you had some expiring this year. They told you were going to have till December 31st. And I'm using the ASE phone app, where you go in there and they send you a question a month, and I'm working my way through those. Occasionally, there will be a question that is worded poorly or doesn't make any sense. But one way or another, I'm going to start on this thing right here. We're going to talk about a little bit of engine performance stuff, and it's some of this stuff you'll know, but I'm just going to run over this stuff because I got some first-time people, that are just trying to get their feet wet, and I figured I'd go into that. Well, you got a machine that breathes, has moving parts, and converts power into motion for the purpose of doing work. That's what we have right here. We got air coming in, we got fuel coming in, we got power, and if it's set up the right way, we'll basically have CO2 going out. And the CO2 is really good for the grass and the trees, nothing really wrong with it. But combining air and fuel to generate force, we got 21% oxygen, 78% nitrogen, and 1% other stuff. Alright, the power is created right here when the fuel goes in. And now that it's not, it's only like 21% efficient, but at the same time, unlike some of the electric vehicles that will only go 200, 300 miles on a charge, I guarantee you, if you ever thought about getting an electric vehicle and you ever make a trip that's more than the more than the maximum range on that vehicle, you'll be thinking, what would I have to do if I was driving this thing and I got 2/3 of the way to my aunt's house in Mississippi or whatever, and I ran out of charge? I'd have to park somewhere where I could get a charge, and I would have to sit there for a few hours and find something to do while I was charging up so I could finish the rest of the way. The good thing about our gas burners is we just stop at the gas pump and go ding, 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 and then we go on, It's practical. Treated exhaust goes out here and feeds the grass and stuff. One of the reasons the grass grows so well beside the road is they have to mow it. Hydrocarbon fuel is what's going in there. And then there you got a transmission and you got your wheels down there. On a non-turbocharged engine, why does the air enter the cylinders? So if somebody just flat out asked you that, what would you tell them? Why does the air enter the cylinders? Well, I can give you a little bit of an idea of how to answer that question, and most of you probably know the answer, but why does whenever you stick a straw in a drink and you put your lips around that straw, why does that drink go into your mouth? The same reason that drink leaves that cup, goes through that straw and into your mouth, is why atmosphere goes into the cylinders. Atmospheric pressure. You start out with a small area, you basically open a port, and whenever that piston goes down, it creates a larger area, just like you're creating a larger area in your mouth, and the atmosphere pushes the drink into your mouth. That's how that operates. Alright, so remember these strokes in order. Alright, see those strokes in order? Let's watch them again. Intake, compression, power, exhaust. Intake, compression, power, exhaust, in that order. Intake, compression, power, and exhaust. Alright, that's watching it happen in 2D. That's just one of your cylinders. On multiple cylinder engines, they have to fire in a certain order and that kind of thing, so just keep that in mind. Okay, so right here we're capturing our atmosphere. We got 14.5 psi at sea level going in through the air filter. After the air has been cleaned and is going through the air filter, it goes to the throttle plate. The reason we have vacuum in the plenum is because we have a throttle plate. When that throttle plate is almost closed and that engine is trying its best to pull air in, there's going to be low pressure right here. Alright, so this is a waveform of what it looks like in there, and a lot of mechanics nowadays are doing measuring this waveform on engine. This is with a running engine. This pattern is not going to look like this if you put your pressure transducer in there with your scope and you're just spinning the engine over. It looks slightly different. But when the engine's running and you got this in one of your cylinders, and I've actually seen spark plugs that will let you put a plug in there and let it actually be firing the plug while you're measuring its pressure, but those are I've only seen that pictured one time. I never had one. But anyway, this right here is your compression stroke leading up. Then your power stroke happens, and it pushes the piston down, and that's at the bottom. And basically, when it gets to bottom dead center and then starts back up, the exhaust valve is open, so you don't have a lot of pressure. But this and this should be equal if everything's working right. Okay, so whenever the exhaust valve closes and your piston's starting back down, you're basically pulling air in. You notice this pressure right here. This is atmosphere and this is atmosphere. See, because the piston's at the bottom. Okay, and then whenever it restarts that cycle, it goes over and over again. You can actually look at this pattern and get an idea of what's going on if you got camshaft issues. Old Mac Vandenbrink could look at an ignition scope pattern and tell you if you got a rounded off lobe on your camshaft, though. So there's different ways of doing that. 14.5 PI, excuse, same deal. Then you got these sensors. You got your mass airflow sensor, got your throttle plate with a throttle position sensor telling the engine controller where it is. Your cam sensor is going to be here, your crank sensor here. You got a map sensor. A lot of the times nowadays you got a mass airflow and a map sensor, because it's always sometimes they may call it a vacuum sensor or whatever, but it's always handy to know what that manifold pressure is in case some of the other sensors fail. And they've got some of the GM, if I remember right, or some of them would actually use manifold pressure to determine whether or not it was getting EGR, because when EGR opens and exhaust gas starts flowing, the manifold, the vacuum will drop a little bit. If you've got one that's running really crappy and you just have started it and the manifold is getting hot, you know that the EGR is flowing typically, especially if you got low vacuum. Now, low vacuum can also be caused by late ignition timing. It can also be caused if you've got a massive vacuum leak close to where you're measuring the vacuum. It can be caused by late valve timing, can cause low vacuum. But if the EGR is flowing, the manifold will be hot, and you'll be able to tell that typically just because of looking at manifold. And so General Motors initially, when EGR was flowing, they would look at the O2 sensor because the O2 sensors are going to, since you're in removing some of the oxygen, it would drift a little rich. So it would know when it was opening EGR, and it would look for the oxygen sensor to reflect that. Just like on the Forge, when you were putting a Ford in a self-test all those years ago, heck, before we even had data stream on Forge back in the 80s, I could, whenever you were running the test, running a key on engine running test, it would actually dump the air upstream, the upstream air, the thermactor system, or General Motors call it air injection reactor. It would dump that upstream, and it would look for the oxygen sensor to reflect that it was getting oxygen up there. And it would work in at 30 to 44 if it didn't see that, so on and so forth. But anyway, that's pretty much what you got going on here. So you're measuring your inputs. Your mass airflow sensor is a really important input. That is a very important input. Any little spider that builds a web in there or anything like that deflects that flow of air. It's pretty amazing. When I was teaching, sometimes a lot of these mass airflows have got a screen that the air has to go through before it goes through the mass airflow sensor. And I have one time this guy came to the Ford place over there, and he said there was a problem with his Explorer where sometimes it would labor knock and ping and not have good power, but he switched it off and restarted it'd be just fine, and it might do it and it might not. It was just wacky as all get out. I couldn't get it to do it. But I said, let me have a look at something here. So I took the top of the air cleaner off and lay it in there on top of the air filter. Between the air filter and the mass airflow sensor, there was a roach's wing, just like a cockroach's wing laying there. And that thing, I said, I bet this thing is jumping up here and going against and landing on that screen and stopping the air from going through that little round hole where those two heated wires are for that mass airflow. So I took that out of there, and he told me he never had another problem with that. All he had was a roach's wing in there. And that's one of those situations where you can go kind of crazy and spend all kinds of money if you want to, but there's not any point in that if you just, think outside the box. Let's do what's cheap and easy first. And sometimes, if you can tell somebody if they got some kind of an idle problem, why don't you wash your throttle body out with a toothbrush real good. Don't spray too much in there because you don't want to, get, plugs wet with too much carburetor spray or whatever. They don't want to hydraulic lock anything. But let's just clean clean that passage out and all that, and the idle air control passages, you know. Of course, I like to have the engine running when I'm spraying the carburetor spray through. The point is, do what's cheap and easy first, because what I'm going to ask you is, are you going to be any worse off after you've done this? Even if it doesn't fix it, it didn't hurt anything. So let's think of it that way, you know. All right. And once again, measuring input. Back in the day, we had carburetors. You know, this basic breakdown of a carburetor. We had a little jet right here, and we had this little venturi. And whenever that air would go through that venturi, it would create low pressure right here, and it would siphon that fuel, and it would mist up, and it busted up, and it would go down through here by the throttle valve. You had your main metering jet there. And you could basically, that's a little brass thing, had a hole in it in different sizes. They would have a little number stamped on it, and you could change the size of those jets a little bit, or drill them out a little bigger if you wanted to horse around with it or whatever. A little bit would make a big difference, though. Sometimes you can mess your gas mileage up like that or create a surge that wasn't there before. But for the fuel to burn eventually, it's got to be atomized. Now, the carburetor did that for a long time. One time I was driving an F-150 back in 1974. In 78, I bought a 74 F-150 that had a 302, 3 on the tree, had air conditioning and all that kind of thing. And that truck only got 7 miles to the gallon. And the first time I filled it up with gas from bone dry empty, it cost me $6 to do that. I thought, golly, what am I going to do? You know, this was back in 78. Well, by the end of the year, Jimmy Carter had deregulated gasoline. It went up to $1 a gallon, and the rest is history. But whenever it went up to $1 a gallon, I says $20 for a tank of gas is pretty high, and I'm using a lot of gas because I was driving 32 miles each way to work and back. And I got a really fine piece of screen, and I put it under my carburetor to bust the gas up a little better, hoping to get better fuel economy. I got a little more power, believe it or not, but I didn't get any change in fuel economy at all. There's another story I could tell about that, but I'm not going to take the time to do it today about that particular set of circumstances. But this would go in through the air filter and down the carburetor and all. You notice I'm not mentioning the PCV system or any of that. Now, fuel injection atomizes fuel better than a carburetor and gives less trouble over time. I don't know how many cars I've driven. The last car that I actively owned that had a carburetor on it was an '87 Nissan Sentra. It was a car that my wife had when we got married, and I bought her a Tempo, and I took that Nissan. And that Nissan only had like 50,000 miles on it when I got it, but that car gave me more trouble than any vehicle I ever drove. Fuel pump went bad, the carburetor, all of a sudden the float started sinking. There's a little screen going into the carburetor that stopped up with crud when I was on a trip to Savannah one time, and I had to figure out what was going on with that and poke a hole in it with my test light probe. It let the carburetor get some gas because it was starving for fuel. And what was funny was one time I went over to the service manager when I was at the Ford place, sent me over to Personnel Resources where this lady was having trouble with her Explorer. And she was she would turn the key and nothing would happen. And so this was happening, and they wanted me to do it. Rather, you put it on the hook and you bring it in, and when it comes in, it ain't giving the trouble anymore. They ever experienced that? Okay, so I was laying under there with a test light, and I was piercing that little wire going to the starter. I told that lady, here, turn your key and let me see if you're getting power, you know. And this guy came walking out of the Personnel Resources and saw me under there working on it and says, oh, you should have bought you a Nissan or a Toyota or something, and you wouldn't be having this problem. And I said, now hold on just a minute. I drive a Nissan, and I got to work on it too, and I have to work on it a lot. And I changed the oil every 3,000 miles. I changed the timing belt when it was supposed to be changed. I changed the coolant when it was supposed to be changed. Follow what's in that book. You're going to do well. A lot of Asian and foreign car owners, German car owners, they will check off every box in that book. But somebody buys a Ford or a Chevrolet or a Dodge, they'll drive it until the wheels fall off without hardly ever changing the oil in it, you know. Anyway, the point is, this kind of system appeared on some vehicles in the late 70s in various considerations. And then it got more prevalent in the 80s. Ford had 40 pounds of fuel pressure on their throttle body injection. General Motors on their TBI just had 12 pounds. And when one of those General Motors vehicles with that TBI has a fuel filter that's starting to clog up, you would absolutely swear the exhaust was stopped up the way that thing drove. But 40 psi is what you had here. That little fuel pressure test port on there. There's a little fuel pressure regulator built in there. There's no vacuum line going to it because this was spraying above the throttle plate. You didn't need to change that pressure. All right, Chrysler, GM and Chrysler TBI were similarly different, yet they were a little bit different than that. You could buy little kits to, rebuild those, put new gaskets in them and all that kind of thing. Dodge had a throttle body injection TBI model. It had one of the little pod-looking injectors on it, and the little ball was getting pitted on those, and it was making them run rich. And so they had a recall program to replace the injector on those Dodges. Well, the mechanics weren't taught or weren't aware of adaptive learning, and that thing had applied its adaptive learning, and with this little injector with the ball, it was pitted. It was, you know, putting more fuel in there than it was supposed to. They would take that a new injector and put it in there without pulling the battery cable off and clearing the memory, and the thing would just run like crap. And so they say, golly, what am I going to do? I don't have time for this. They're not paying me enough to do this. So they put the old injector back in there and let it go. Well, adaptive learning was what the reason for that was. And you might remember me telling you about my dad with my mother's Chrysler. It was running too cold, and threw a code 17 on that old 91 New Yorker. And whenever I told him to put a thermostat in, he did. And 2 or 3 weeks later, he changed the oil. After that, wouldn't idle because the gas was all contaminating the oil, and it was pulling it through the PCV system. The adaptive learning had come, and so when he changed the oil and that gas wasn't there anymore, the adaptive learning was so far off the car wouldn't idle. And so all he had to do to fix that is pull the battery cable off and all. But anyway, so port fuel injection, 1 per cylinder. And you get fuel injectors here, it's real common. Usually on a regular car, you know, these fuel injectors, you might notice that these little caps on the top of them are different colors. On your Fords, the gray one is a 14 pound per hour fuel injector. Engineers figure fuel in by weight, not volume. So 14 pounds per hour. The orange ones, like the Mustangs had, at 19 pounds per hour, and so on and so forth. So that's how those injectors were classified, was how much fuel per hour they would spray. All right, so you got your fuel rail here. Fuel pressure regulator would return to the tank. Later they started putting the fuel filter and the fuel pressure regulator in the tank on some of the vehicles, and that made it very unusual. I had a Dodge van I was working on one time, had V8 in it, had a skip on cylinder number 1 that was very, very mysterious. And it turned out, what I figured out on that one, that thing was sitting in there at a little bit of an angle, and the fuel pump was cavitating, and it was putting bubbles in the fuel rail, and the highest cylinder on that fuel rail was number 1, and it had air there all the time. I don't even remember how I figured that out, but whenever I finally did figure it out, it was like, you know, illumination there. And so I put a fuel pump in that one and fixed that skip that was on number 1, because I got rid of the air that was in the fuel rail because the fuel pump wasn't cavitating. When the fuel pumps first came out, they didn't have any lubricants in the gasoline to lubricate the fuel pump, and they were wearing fuel pumps out just left and right. And they'd get noisy, and they'd make air, and it was just awful. And whenever they'd get hot, they would fail, and so on and so forth. The basic principle here is you get your crank sensor, you get your PCM, that gives you your fuel injector pulse. Frequency of the injector's firing is determined by the crank sensor. Click, 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 click. The timing of their firing is determined by the cam sensor, which one is number 1. The pulse width, now this is a generalization, you know, there may be other ones that are slightly different than that. But the pulse width, with the amount of time the injector is open, is determined by the other sensors, which measure engine load, airflow, manifold pressure, how you're moving your throttle, so on and so forth. You know, when it detects that it's loaded, the cadence of the injector stays the same for the most part, with one example, one exception that I'll tell you about in just a second. But it's squirting the same, it's clicking the same amount of time, it's just opening the injector wider every time it opens it. Now, when you're applying your throttle, you remember on the old carburetors you had an accelerator pump. And what I like to do is open the choke whenever one went to start. I'd open the choke and I'd hit the throttle, see if I saw fuel squirting out of the accelerator pump. The accelerator pump was basically there so that it would wet the manifold when you was first setting the choke, and because of the fact that it takes a second for this carburetor to start delivering mist, that spray out of that accelerator pump would keep the car from having a little bit of a stumble. Well, the same problem is going on with these. You get a bunch of extra squirts on your injectors on most of these vehicles during the period, if you can actually measure that, during the period when you're applying your throttle. I discovered that whenever I was using portable vehicle analyzer on the service bay diagnostic system, because it would show a bunch of extra fuel pump squirts on that little square wave indicator of what the injectors were doing. You know, it makes sense. The engine still needs the same thing it always needed. Alright, here's how it's wired basically. Typically from B plus you're going to have a relay that's turning your injectors on, and then your engine controller is going to fire them, things like that. Most of the time it'll fire them all together when you're starting it, because of it doesn't have that pulse, for the accelerator pump. It actually has to create its own extra fuel to wet the manifold. Some of your earlier Asian vehicles had a cold start injector, and the only time it worked was whenever you were starting it cold and it was spraying in there. And then they'd have the German cars would have an auxiliary air regulator, which was kind of like an idle air control, but it was a bimetal strip that it would open up, leave it more air, and then as it warmed up, it would close off. That was mysterious stuff when I first started working on that thing. Anyway, you capture the injector scope pattern on the trigger side. If you want to get this pattern, this is how long the injector is open. When it closes, you get about a 50 to an 80 volt spike right here, but you're going to capture it between the injector and the engine controller. This 12 volts is actually coming through the injector, and whenever it's shorted to ground by the engine controller, that's when it pulls it to ground, and this is when it releases it. So your pulse width is here. This is voltage over time, right? All right, so Sun Tzu, the art of war, is often quoted by saying, know your enemy. 1, the customer is not your enemy. 2, the vehicle is not your enemy. 3, the customer's concern is your enemy and must be defeated. And 4, to defeat the enemy, you must gather intel and sort it out. All right, some rules hadn't changed. Carburetor or fuel injection, it doesn't matter. An engine needs a proper amount of extra fuel on the first cold start, but not too much. It needs more fuel in the mix than a warm engine. In other words, a cold engine needs more fuel than a warm engine. When the throttle is open, extra fuel is needed, though, even on a hot day, or on a hot engine, I'm sorry. So if you're giving it gas, you're getting some extra squirts here because you need what the accelerator pump used to provide. Too much fuel will get a black cloud, there's your hydrocarbon cloud, or a no start and wet spark plugs. If the spark plugs are wet, the spark runs on the wet, it doesn't jump across the gap, and that's why a flooded engine does what it does. You can take that, you got to be careful when you're doing it, but you push the accelerator pedal all the way to the floor on a lot of vehicles. Some of them no, but a lot of them they will push it all the way to the floor and spin it over, and it will not start because it kills the injector just in what you call clear flood mode. Now you got to be careful when you do that. Be ready to let off if it starts, because it may have some fuel puddled up in the manifold and label it to start. But think about that. If you got a throttle position sensor that's reading wide open throttle, it may keep it from getting any fuel injection. And so, look for your codes when you do that. Back before we had data stream, I used to have to measure voltages on all the Fords, and I got to where I knew what the voltages were, knew what it was on a normal vehicle. I'd measure all that voltage, and whenever I came up with a voltage I didn't like, or I was sweeping the TP sensor through watching it drop out, I was, 12, 15 drivability jobs a day I was working out back in those days, and they got used to that cadence, and it was lucrative, but it was also kind of mind-numbing whenever you had 4 or 5 customers waiting at the same time, and one that's giving you a hard time. You can't always figure out every single problem, in 10 minutes. I got pretty good at that in the day. Different rules apply whenever new cars come around and all that, but whatever you're used to is what you're going to be good at. High fuel pressure, a saturated canister, a stuck open injector, a ruptured fuel pressure regulator diaphragm. If you pull a little vacuum hose off that fuel pressure regulator and it's got fuel in it, that regulator's got a busted diaphragm. That ain't rocket science, okay? Fuel burns more efficiently the better it's atomized. The smaller the droplets, the better the burn. That's why carburetors gave way to fuel injection in the first place, and that's why GDI fuel systems are replacing regular EFI. The smaller the droplet, the cleaner the burn. You also get more power like that. This one here, he said it ran rich when you first started it, puffs black smoke till it warms up. He didn't have data stream, he didn't think. He did. When I found out on those Fords, whenever they started having to reprogram it for like the E4OD transmission shift or something like that, they would go ahead and put data stream in there. Well, this one here had an AOD. The scan tool lets you see things like fuel trim we can't see with hard measurements. You cannot measure fuel trim with a scope. You're going to have a scan tool look at giving you a window into the system. Knowing what the PCM's thinking is pretty important. And see, there's your fuel trim. It'll tell you got an issue there that is corrected rich. So I checked the OBD2 connector and I found these 2 wires in here. I said, you got data link on this thing? He said, well, I told it the truth about the vehicle and they wouldn't let me have data stream. That's right, I said, but lie to it and tell it you got an E4OD because this thing's got data stream on it. He was using the NGS too. So he lied to it, and he had data stream. Figured it out really quick. All right, so what we did was, the sand school doesn't work. We need to gather data the old-fashioned way, checking individual sensors using the scope or whatever. But this wasn't one of those times. We saw the throttle position sensor floating all over the place. You remember those extra pulses I was talking about? This one here, when you first started up, the TP sensor voltage was floating around, and it was causing it to have more, extra injector pulses that it didn't need, and making it puff black smoke. And it would kind of clean up his act after it warmed up. That's what the problem was. This one here had never happened while the guy was driving. It was an old Camry, but she reported it was likely to quit or fail to start several times a day. I've talked about this one before. I'm just going to rush through it. We could dig for the non-com problem because it wouldn't communicate with our scope, or we could attack it the old-fashioned way. All right, so I'd worked on Fords for years without data stream by back probing sensors to gather voltages. It's not fun, but it's something you can do. Knowing what to expect is a good thing if you've measured a lot of them. We fired it up, waited for it to quit, and it quit. We had spark, we had fuel injection, which told us the crank signal was present at the ECM. If that thing's popping spark and it's firing injectors, you know you got a crank signal. Okay, that's pretty much what it is. What about some weird ignition timing concern? Well, with the timing lock connected to the number 1 wire, the spark event was happening at 5 degrees with the engine spinning, which was totally acceptable for a successful burn. Typically when you're starting one, the timing will be down. On the old Model T pickup trucks back in the 20s, there was a lever on the steering wheel where you would retard the timing before you'd use your crank in the front to start it. If you didn't do that, it would kick back and break your arm. Well, nowadays, when you're starting one, it retards the timing pretty much the same way. It just does that automatically. We don't have to think about it. All right, so we try something quick and easy. I shot a little carburetor spray in it to see if it would start on that, but it wouldn't. If fuel starvation had been the case, that would have been it. So we've got to put on the gloves and get tough. There comes a point when things get personal, it's you and the machine, right? All right, fuel pressure testing just because. So I connected the fuel pressure gauge and take a little banjo bolt out, put it in there. We had an adapter for that. And you don't need an electronic gauge to do it. Let it run till it quits again. May take several hours, and if the pump's bad, you'll walk by and see the pressure has fell off and it has died. This one wasn't doing that. Heard 41 psi fuel pressure. Had to check for water in the fuel, so we pumped a few gallons of fuel out of the tank, see if any water appeared. It didn't. Test for alcohol, found 2%. Now it was time to bust out the scope. What we found was a really wide pulse. I mean, this was incredibly wide. This was what it was doing when it wasn't starting. All right, this is a normal pulse when it was starting, and this is the wide pulse when it was not. So it was starting when it looked like this. And that was crazy. So I targeted a time when it was starting just fine. I disconnected the fuel pump to see if it would make a wide pulse like that. So with the fuel pump disconnected, it was only about that wide. But there's your normal pulse. Well, okay. So the crank and cam sensors provide injector timing on speed density systems, but the ECT, TP, MAP, and IAT are modifying input. So I started with the easiest sensor to get to, and I found the problem. Look at that. Nearly 5 volts right there at the engine coolant temperature sensor. And when we scoped it, we got this right here. It was wide open, and then it would start rattling around like this. And so we wound up putting an ECT sensor on that one and took care of the problem. Being able to think clearly in a situation like this is what's really important. And a lot of the times, you kind of got to be a detective, and you got to say, well, this is what I know, and this is what I'm not sure about. So you're gathering data, and you're putting it together to recreate your crime scene or whatever. A lot of the scan tools nowadays are pretty cool because, like for example, if you're working on an anti-theft system on some of these vehicles, it'll tell you which panel, whether it was a hatch or one of the doors, which door it was, or the hood, it lit off the anti-theft system. If the cruise control dropped out, it'll tell you if it was the brake or the speed or whatever that kept the cruise from engaging. There's just all kinds of cool stuff that they've actually typed into these scan tools using this algorithm now. But the point is, all of these vehicles, any engine controller is going to have input. Now, also you've got this CAN bus stuff going on, networks and all that. That changes it a little bit because sometimes you'll have speed signal, for example, is generated by the speed sensors going to the ABS, and the ABS will feed it to the engine controller, and you basically have to track it back on stuff like that. But I hope you got something out of this video. This is always a lot of fun for me. I've got like 11,000 subscribers. I know most of the people that are subscribing aren't watching it. And I hope it was good enough to where you watched it all the way to the end. But you guys have a good week, and I hope you do really well, and I hope you don't find anything you can't figure out. And I will talk to you next time.